Hi, we are a group of computer science students from the University of South Alabama in Mobile, Alabama. Our team consists of Jenna Frisch, Jared Nicase, Alan Piasnak, and Trey Williams, and we are working with representatives from the NSA on an open source project called Kmyth, which utilizes a TPM, short for Trusted Platform Module. And to really simplify, you can think of a TPM as a small processor with a key that is built into hardware when it is manufactured, and that key cannot be accessed by any type of software. The TPM can be used to encrypt a small amount of data. For example, another key that you might want to use to do symmetric encryption on a larger piece of data. Microsoft, for example, uses TPMs in this way for BitLocker, which allows them to encrypt your entire hard drive, and the only way that it can be unsealed is with the same TPM that sealed it. Now, inside of the TPM, they have platform configuration registers, aka PCRs. Again, simplifying, PCRs are registers that allow you to measure information about your computer. For example, your BIOS setting or your boot record. However, if you do any modification to your BIOS or boot record, or if you were to do a firmware upgrade, it would change the values of your PCRs and make it so that you can no longer unseal that key. And of course, that means you can no longer unencrypt that data. In an analogy, it's kind of like giving the key for your car to a valet, and you expect them to protect that key and make sure nobody else can have it. But then you go and get a haircut, and the valet doesn't even recognize you anymore, and then they refuse to give you back that key. And now you no longer have access to your car. Now, this is a problem called PCR fragility, and we've been tasked with coming up with a solution for it. So for this demonstration, we have a file called USA, and inside of it, you can see it says University of South Alabama, go Jags. And we will be using Kmyth to seal and unseal this file. Now, the first thing we need to do is start up a TPM server. This is an emulator. Type in our password. And then the next thing we have to do is log in using the user TSS, and this will allow us to connect to that TPM emulator. So if we again type in our password, we get this warning, but it's basically just telling us that our configuration is now different. Before we were connecting to the actual physical TPM, but now we're actually connecting to that emulator, which we want when we're kind of developing and not trying to break our TPM in the process of debugging things. So if we open up our program, we have two primary functions. One of them is called seal and one is called unseal. And just to give you kind of a visual of what's going on, we can do TPM2 PCR read SHA-256. And that will show us all the values of our PCR registers right now. And you can see they're all zeroed out. That's how they start when you start up the TPM. And the only thing that can be done with these PCR registers is that we can do an extension. So we can take the hash that we have now and then some other future hash and hash those together. And then we get some new hash that comes out of it. And the TPM can actually use different hashing algorithms, but we're using SHA-256 in this example. So going back to that analogy, if somebody else wanted to get that key that I gave to a valet, the only way that they can do that is that they can beat the SHA-256 hashing algorithm. Because these values are based on something that's going on inside of your computer, but we have no idea what the input is. All we know is what the output is. And the only way that somebody else could get the exact same output that you have is if every single part of their BIOS and boot record, depending on how you decide to seal the object that you're trying to create, is if every single part of their computer matches every single part of your computer based on how you decided to seal the object in that TPM. So before we show you what we've done, we can look at how Kmyth was functioning prior to us actually making any modifications. Kmyth was already able to seal and unseal an object against certain PCR values. For example, if we said we wanted to seal against PCR 0, 1, and 2, which we'll do in this example, then that means that PCR 0, 1, and 2 all have to match whatever we have in this value in order for somebody to unseal that data. So if we look at our configuration real quick, we're basically making a call to the seal function, but we're passing it in a couple command line arguments. Here we have the path to the USA text file that we looked at earlier, and this is the data that we're ultimately going to be encrypting, but when we encrypt it, we end up with a key that needs to be protected by the TPM. And then we also have an output path, which means that after encrypting all that data, we're going to be storing the information about that key in this usa.ski file. And then finally here, we're indicating that we want to seal against PCR value 0, 1, and 2, as I mentioned earlier. So if we go ahead and run the seal, we can see that Kmyth has outputted this usa.ski file. And if we look at the contents, this is what the ski file looks like. So while you can't really decipher what's going on looking at this text, here you can see information about the PCRs that we selected, in this case 0, 1, and 2. And then there's also a bunch of other information about the keys that we won't get into the details of. One thing I did want to point out in this ski file, when we create our own implementation of this program using what we call policy or, we're actually going to modify this file and it will look something like this, where we have policy branch 1 and policy branch 2. And then of course you'll see some data underneath each of these. I'm just copying and pasting for convenience, but I'm going to go ahead and discard those changes. We don't need them. I just wanted to bring your attention to that so you will recognize that difference when it happens. So the next thing we can do is unseal. So we go to unseal. Again, let's look at the configuration. For the input path, we have now a path to that usa.ski file that was generated from the last step. And then we also have an output file. And this is where the final output is going to be generated. And we're going to remove that -p. I'll talk about that later. But again, all this functionality is something that already existed inside of Kmyth. So we click OK here and then unseal. We can look back at the desktop and we can see that we have this output file now. And if we open it up, we can see the exact same text that we had in this file here. So to recap, what happened with Kmyth was we fed it this file. It took all of the data in that file and then encrypted it using a symmetric key. And then it took that symmetric key and then sealed it with the TPM. So the symmetric key can now only be unsealed by the same TPM using the same PCR register values. And the information about that symmetric key is stored in this file here. Again, not going into all of the details, but then we passed that information back to Kmyth when we did the unseal function, and it checked the PCR values to make sure that they're the exact same that they were when we actually sealed the key. So you'll remember they were all zeros. And if we do a PCR read, you can see that they're still all zeros. If these values were anything other than all zeros, then the attempt to unseal that key and decrypt that data would have failed. And so we're going to prove that real quick. I'm going to delete this output file, and we're going to leave this ski file. This is all the information about the sealed symmetric key. And right now it is currently protected, and it can only be decrypted by that TPM. And we're going to run another unseal, but before we do that, we're going to come down here and we're going to add in a couple lines of code. And the only thing this code does is take those PCR values and take in a random hash where there's nothing special about it. And it calls a function to extend all three of those PCR values. But because we're actually extending the values of the PCRs before we call that unseal, the attempt to unseal the key should fail. So we're going to run this. And you can see we've gotten an error here basically saying a policy check failed. And now if we look at the value of our PCRs, you can see that the values of 0, 1, and 2 are all different. Of course, they all match each other because we used the exact same hex value to extend each one of them. But that's not an important detail. The point being that the TPM looked at the PCR values, saw that there was something different than all zeros, and the TPM said, no, you're not going to get access to this key. But let's say that we're the owner and we've done a firmware upgrade. And then after that firmware upgrade, this is what our PCR values look like. Now we no longer have access to our own key. Again, going back to that analogy, it's like we got a haircut, but now we have no way of proving that we are the rightful owner of that key because the TPM no longer recognizes us. So now we can talk about some of the things we added to Kmyth. So in this demonstration, these values represent our computer after we've done some kind of firmware upgrade. So what we can do now that we couldn't do before is go to edit config, add in a flag for -G, short for get expected policy, and click apply. And then we can run the seal function one more time. This is not actually going to seal anything. The program is actually going to terminate early before it tries to seal anything. So I can run this, and you can see it's giving me a value here. And this is the value that would represent the policy if my PCRs looked like this. So let me go ahead and copy that real quick. And I also want to delete this usa.ski file. And now we're going to do the whole thing over again, but this time we're going to be using our policy or implementation. So the first thing we want to do is log out of the TPM, restart it, because whenever we restart the TPM, the value of the PCRs go back to 0. And we're now trying to do a demonstration of what our new policy or looks like. So now if we look at our PCRs, you can see that 0, 1, and 2 are all 0 again. And if I go to edit configuration, I can modify my argument for the seal. And this time I can pass in E, which is the expected policy. And then I can paste in that value that I got previously. So if I click apply, now I will try to run the seal. And we can see that we have our usa.ski file. However, this time you can see that we have policy branch 1 and policy branch 2. And these represent the two different policies that we could use to unseal the key now. So the first one here represents the policy created with the value of PCRs I have right now. And that's with everything zeroed out. But then we also have this other policy that we passed in. That was that string that we generated. And that is the policy that would result if we did that PCR extend and had those values that we saw earlier in the PCR registers. So real quick, we're going to do an unseal, noting that these are currently the values we have in the PCR. And if we go to run, edit config, we do need to add a flag indicating that we're using a policy or. We'll click apply, and now we can run the unseal. And now you can see we have this output file, and we get our text back. Now this is kind of the same thing that we already saw with the original implementation of Kmyth. To actually prove our implementation is different, we can once again go back up to here where it says unseal, and then right here where we added that code earlier, we're going to add it one more time. And now we're going to extend the values of those PCRs using the same value that we gave it before. So we'll end up with the same PCR register values that we had before. And the policy that we generated should be able to satisfy the TPM and allow us to get access to our data. And once again, going back to that analogy with the valet, it's like telling them, hey, this is what I'm going to look like if I get a haircut. So I want you to give me back my key if I look like I do right now, or if I look like I do when I've gotten a haircut. Which in real life is a silly example, but with the TPM, it is incredibly protective and will only allow you to have that key if it's 100% sure that it knows that, you are you. So now we're going to run that unseal again. And if we look, we can see that our output once again is generated. And if we look at our PCR values, we can see that they're now different. And these are the exact same PCR values that we had in the previous example. And we generated a policy for it. And we knew that these PCR values were exactly what we were going to get once we did that upgrade to our computer. Now let me copy this real quick. One more time, I'm going to restart the server and log back in. So if we look at our PCR values again, you can see they're all back to 0. We can go back and uncomment out that code that extends the PCR values, but all we have to do is modify one little thing. So now that if we try to unseal the file again, it won't allow us to do the unseal. In fact, it says here, policy check failed. And that's because even though we only made a small change to our input values to the PCRs, we can read the PCR values that we have, and you can see the output that we get is this right here. And you can compare that to the output we got earlier, where all we did was use a 5 instead of a 4. So that means the only way that somebody else could get that key that is being protected by the TPM is if every single value that they give it is exactly the same as the values that you approve of. So normally this might be your BIOS and your boot record. So when you start up your computer, there's a whole chain of events, and every single item in that event has to be exactly the same because they each get piped into the next part of that sequence. And only if everything is exactly the same will you find yourself in one of the two states that are approved by the TPM. So to recap, what we have shown is that we can do an update to the system. We can use the new get expected policy argument to find out what the resulting policy will look like once we have done that firmware update. Then we can roll back the system, and then we can seal an item so that the only way that it can be unsealed is if it is one of those two approved states. Meanwhile, anything else will be blocked out and prohibited from being able to unseal that key, therefore maintaining the security of the key and the security of the data that you've encrypted with that key. And that is all we have for our presentation today. Thank you for taking the time out to view this demonstration. And from all of us at the University of South Alabama, have a great day.